Okay, started up the video again. Here's the state transition diagram that we're going to program. If you're watching this video instead of in the class, I would recommend that you bring up the resources on Blackboard so you can see what all we're talking about. We have the luxury of having a whiteboard with the state transition diagram, and you won't as you watch this video. Anyway, we're going to convert our state transition diagram to a program via Excel. Now, there's a lot of steps to this. If you want to take notes, you can. Of course, you'll have the video to reference. So let's start off with, do you have a lot to print? Let's start off with the inputs and outputs. I'm going to leave myself some space, and you'll see why here in just a moment. Let's see, 1, 2, 3, 4, 5. I'm trying to recreate what I've already got on Blackboard, so I don't have to upload this as well. So just like in step programming or sequence programming, if you want to call it that, we've got to collect our inputs and outputs. So we have a start push button that's involved with this state machine. It's okay. It's not all that formal. We've got a stop push button, we've got the prox sensor, and we've got the level sensor. Now, I'm not going to go into Logix Pro. I will just write down the addresses because I have them here. These are all inputs, and here are their bit addresses, so we can reference them later. Now, on the output side of things, let's see, we've got outputs here. We've got the motor and the valve. Those addresses are O:2/0 and O:2/1.
Can you make that bigger?
I can try. Let's see if I do this. There we go.
Thanks.
Better? We're going to have quite a bit on the screen, so we'll have to scroll. We'll have to decide if we want to scroll or if we want to make it smaller here in a minute, but for now this will work. Now, there's a couple different ways we could do this. Remember how when I made a sequence machine before, I used I set aside one bit for each of the steps. And then last time I did it, I used only 2 bits and the different combinations that those bits could have. When you use bit combinations, it's a little more complicated because the bits are not independent anymore. They're a group, right? To indicate what step you're in, you have to consider all the bits together. It works the same way here. So I'm going to simplify the state machine by simply creating all of these state bits, but I'll have all individual state bits. Let me explain. So for the stop state, for example, I will set aside a bit at address 0 in memory, in the bit's memory, that will indicate that I'm in the stop state. Basically, if this bit is on, I'm in the stop state. If it's off, I'm not in the stop state. Okay? So I'm going to abbreviate this as B0. All right? That's just what I'm going to call it temporarily. I'm going to give it a name. The get box state, I'm going to assign bit 1 to that, and I will just call that B1. The fill box state will be bit 2, and the full box state will be bit 3. And I'll abbreviate these B2 and B3 so I don't have to type B:0/3, for example, every time. Now, basically the way it works is if one of these bits are, if one of these bits are on, then that's the state I'm in. In other words, it should be set up so that only one bit is on at a time. Make sense? I would never have 2 of these bits on at the same time. Okay, so now I've laid the groundwork for what I need to do, and now what I need to do is actually program each state. Let's start with the stop state. Okay? In the stop state, what bit is on? B0. That's the bit that when on indicates we're in the stop state. Now you might look at this and say, well, how are we going to turn it on? Well, I'll show you, don't worry. Our program will turn these bits on and off to move us between the states based on the transition conditions. All right, now, if you look up at the state transition diagram, what is it that can get us out of this state? I'm not interested in what can get us into the state, just what can get us out of the state.
Start.
Right, so start equal 1 can get us out of the state, right? So start is the only input condition that I care about. And start can either be a 0 or a 1. Those are the only possibilities, right? If start is a 0, that means the start button's not pushed, and we need to take the null transition. We need to stay in the stop state. Make sense? But if the start button is pushed, then we need to go to the get box state. So I could say the next state, based on start, if start is 0, well then it's the stop state. That's the next state that I need to go to. In other words, I need to stay in the stop state. If start is equal to 1, then I need to move to the get box state. I'm going to put some decoration around this. Outline it so we can see it. Okay? So what I've done so far is I've just said, here's the input, here's all the possible combinations of the input. Since it's a single input, it's either a 0 or a 1. And I've decided based on what the status of that input is, whether I should go to, or what state I should go to next. Okay, so now I'm going to put more detail in it, because really what I need to do to stay in the stop state is I need to set B0 and clear all the other bits. Now here's the nice thing about this programming. We only care about setting the bits. We don't care about clearing. That will come along for free. Okay, so let's see, let me get enough space here. There we go. Let me write down the input again, all of its possible values. Note that I'm trying to decide what the next state is. And here's what I want to do. This is where the rubber meets the road, okay? What I'm going to do is create a Boolean algebra expression to calculate B0, okay? Now, if start is equal to 0, that means I need to stay in the stop state. I need to stay in the state I'm in. So I need something that will evaluate B0 to a 1, that will set B0 to a 1. I need to calculate B0. I need to set it to 1. The only thing I have to set it to 1 by is the start button, and here's the key, the current state that I'm in. Okay? The equation that I'm setting up should only affect B0 when I'm in this state, because B0 may need to be shut off in another state. Does that make sense? So my equation would look like this. The first condition is I have to be in this state. I have to be in this state that I'm programming before this equation can take effect. Now there's another condition. So I'm going to say and start has to be off. Does that make sense? Let's dissect this for a minute. It's a real simple idea, and I think it'll be clearer in just a moment once I write down the equation for this part. Think about it. You're the PLC. Right now, B0 is equal to 1. If B0 is equal to 1, then if this was a ladder, a rung, an expression, B0 equal to 1 gives you a 1 there. If the start button is not pressed, then 1 and the inverse of 0 is 1, and you're going to set B0 to 1. In other words, you're going to stay in the stop state. Right? So let's consider the next one. If we're in the stop state and start is pressed, then we want to move to the get box state. how do you move to the get box state? Well, you have to set B1 on, right? So B1 equals, remember, the first condition is always that you are in this state. Okay, we're programming this state, so it's the state bit. So the first condition is B0 has to be true. If B0 is not true, I don't want this expression, I don't want this rung to affect B1. I don't want it to do anything to B1. Okay? As a matter of fact, it actually would do something that would turn B1 off, but I don't have to worry about that part. I don't want to turn B1 on unless I'm in the stop state. Okay? And the start button is pressed. So I have to say and start. Now I'm going to challenge you guys when we're programming the next states. I'll go around the room and ask you what I should write for the expression. So try to wrap your head around this. Do you have any questions about these expressions? Do you understand that I can make a rung of ladder logic that will have this condition ANDed with the inverse of start and write the output there? I can write another rung of ladder logic that will have this address as the output equals this address as an input ANDed with the start button, which is right there. Okay? And that will effectively, these equations will calculate the transitions from the stop state for me. That's what I'm doing. I am programming the transitions. Okay? So far, what have I done? I have programmed the null transition, that's right here, and I have created an expression to program the transition to the get box state, and that's right there. Okay? Any questions? All right, then let's go on to the next state. Let's program the get box state. In the get box state, what bit is it that's set if we're in the get box state? All right, I have to start going around the room. Mr. Christie.
B0/1?
Yes. B:0/1 is the bit that is on if I'm in the get box state. Now, we've got a small problem. Do you notice in the get box state that we've got two different possible transitions? Well, three really, because we've got the null transition, we've got the prox equal 1 transition to fill box, and we get the stop equal 0 transition. So now we have two different inputs to consider. Now, with two different inputs, how many combinations are there? 4, right? They would be, say, prox off, stop off, prox on, stop off, prox on, stop on, or prox off, stop on, right? Those are the different combinations. And so now, my consideration is a little more complicated because watch. What I have to do, try to make this look nice. Let's make sure that I've got the right place. Oh, I see. I need to insert a row. There we go. Merge and center this. The stop push button is one of the inputs I have to consider in order to decide what transition to take. Now that stop button will either be giving me an off or an on. Now, the stop push buttons are a little bit confusing because they're normally closed, so this would mean that the stop push button is not actually pressed, and this would mean that it is pressed. So we've got to keep that straight. But the other thing I have to consider is the proximity sensor. And that prox sensor could either be off or on. So do you see what I'm doing here? I'm setting up an array with all possible combinations. This box would represent prox off, stop off. This box represents prox on, stop off. This one is prox on, stop on, and so on. See? So what I have to do is decide. Look like that. There we go. What I have to do is decide what state I should go to. Now, think with me for a minute. In this box, the prox is off and stop is giving me an off. So is the stop button pressed or no?
It is not pressed.
It is Remember, by default, the stop button gives us a 1. If it's given us a 0, it must be active.
Outcome, so it's
Okay.
a
So it's
not,
pressed.
like a not case, so it, or
Sort of, yeah, it's
the
more
inverse of
the,
what it should be.
right, right. So it's opposite to what you would think it would be.
Okay.
So if the stop button is pressed and prox is not true, and remember, I'm in the get box state, I'm trying to get a box. Where do I want to go?
Toolbox.
I don't know, I don't want to go to the fill box because I don't have a box in place. Remember, prox is equal to 0. Where do I want to go? Stop button is pressed, so I want to go to stop state, right? So the next state would be the stop state. That's where I want to go if the stop button is pressed. What about if the stop button is not pressed and the proximity sensor is not true? That's this one, right? Because the stop push button is normally closed, so it's not active. It's giving me a 1. Prox is not true. That means there's not a box in place. So what do I want to do here?
Stay and get box.
Stay and get box. So my next state is the get box state. All right. What about over here? What if the stop button is not pressed, but there's a box in place? That's what prox true means. What do I want to do?
Fill box.
I want to go to fill box, exactly. Now here's the last one. We actually have to make a harder decision here. If prox is true, that means there's a box in place. But look, the stop button is also being pressed. Which do we want to take priority? Do we want to go to the stop state, or do we want to go to the fill box state? It's up to you as the programmer. You can actually decide. Now, as human beings, when we press the stop button, we expect the darn thing to stop, right? So I would vote for going to the stop state here. That's what I would recommend. Okay? I think the stop would override prox. I think it's more important than prox. So let's just go to the stop state in that case. Okay. Well, I'm going to cheat a little bit, and I'm going to copy this, and I'm just going to paste it over here. Because it's really the same thing. All I'm doing now is trying to decide, actually let me undo that. All I'm trying to do is figure out what the equation should look like. So if I want to go to the stop state, Mr. Christie, I've already picked on you. So, Mr. Shepherd, you're in line. How should I begin this equation? Remember, I want to go to the stop state. So what bit is it that I want to turn on?
You would want to turn,
To get to the stop state, what bit has to be on?
would it be the stop button?
Not the stop button, what bit do I want to turn on? Don't look at the transition diagram, it will
Oh,
help you
bits
look
up
at the
there,
state bits.
If you wanted to turn the whole thing off, you would need to turn B:0/0.
Exactly, so we want B0 equal to 1. So we need some expression that will put a 1 in B0. Good. Okay, Mr. Shalaski, let's go to you next. The first condition is always that I am in the state that I'm transitioning from. Does that make sense? So what would my next expression be? What should I add in next to this equation? What indicates the current state? What state am I in, first of all?
Stop state.
No, I'm not in the stop state yet. I'm going to get there. My current state that I'm moving from is, it's right here.
Get box state.
We're in the get box state, right? So the first condition is always that we're in the state we're calculating from, okay? So what bit would be set if I'm in the get box state?
Bit 1.
B1. So there's my first condition. I have to be in this state before this equation should do anything. You see? If B1 is a 0, then this equation is just going to calculate a 0 for B0. But if B1 is a 1, then I can possibly get a 1 and go to a stop state. Now I have to next consider the input that's causing the transition. What input is causing the transition to the stop state? Mr. Collingwood?
The stop button.
The stop button is, that's right. So what should I add next in my expression? Remember, I'm anding, and I need to get a 1.
You need what?
I am anding, and I need to calculate a 1 here. So I've already got a 1 here, because I'm already in this state. I'm gonna and with something that had better be a 1, so that I can get a 1, and thereby go to the stop state.
Be the inverse of the stop button. right?
Exactly, very good. See? So it's the stop button that's allowing me to go to the stop state, okay? And so that's how I'm going to calculate, you know what? Here, let me fix that. It's the stop push button, there we go. Now, technically, there is actually another condition here. Ms. Weigel, can you see what that condition might be? What are the 2 inputs we're looking at to consider moving from the get box state? What 2 inputs give us roads out or transitions out of that state?
Null and box.
Well, not null. Null makes us stay in that state. Prox is one of them, but there's another one.
Stop and box.
Stop and prox. Stop and prox allow us to get the heck out of Dodge, right? Okay. So we've got one of those inputs represented here. Could we add in the other one? We could. So how would I add in the other one? What should I and with to include the other one?
Box equals 1.
Not quite. Notice that it came from here, where stop is a 0, so inverted stop, and prox is a 0. So what should I do with prox then? Don't feel bad if you don't know the answer. That's why I go around and put every student on the hot seat, and then they begin to understand it more. I don't know why it works. I just know it works. It's the only way I know to teach this, otherwise students don't get it. So we're trying to get a 1 here. So far, we're in the state, so we've got a 1 there. And with the inverse of 0, so that's a 1. 1 and 1 is 1. And then we're going to and it with hopefully the inverse of prox. See? Because this is the input combination we're trying to use to get us to the stop state. So we have to and with the inverse of prox. Okay. All right. So there's our full expression for moving to the stop state when prox is off and stop is off. In other words, stop is actually being pushed and we're in the get box state. Okay. That's okay. We'll come back around. We'll go around many times, and you guys will have it by the time we're at the end. Okay, let's program the get box transition. So this is the null transition. So we're programming this, and where are we? Mr. DiBenedetto, how should I begin the equation? What bit am I trying to calculate for?
B0? No, B1.
B0 or B1? I don't know. What do you think? And why?
I do not know why.
Don't know why. Okay. We're trying to go to the get box state. The only way to go to the get box state is to affect the bit that indicates we're in that state.
So B1.
B1, exactly. Good. Mr. Christie, I'll come back around to you. What's the first condition I should add in here to this expression?
See the inverse of B0?
Don't think so, because the inverse of B0 would say that we're not in the stop state. Well, that's not precise enough. We need to know that we're in the get box state.
Right.
So how would I say in the get box state? I know it's strange, but this is actually easier than it used to be. I used to really confuse the students by using combinations of bits instead of having one bit for each state.
I don't know.
Okay, that's all right. Well, here's the thing. What confuses students is anytime the null transition happens, you're calculating a bit to go into a state you're already in. And so the condition is always that I'm already in this state, okay? It's always, anything over here, all these equations are gonna have B1 as their first expression, always. Because I don't want these expressions to do anything if I'm not in that state, you see? If B1 is a 0, then I'm not in this state. And if B1's a 0 in any of these equations, these expressions are out the window, okay? So that's how we make these equations. I mean, look, here's one expression for B0, here's a totally different expression for B0. How do we rectify that? Well, this one only does something when we're in this state, and this one only does something when we're in that state, you see? That way there's no crosstalk there. Remember how we couldn't allow both the up and down motor windings to be energized at the same time? It's kind of what we're avoiding here, okay? So the first condition is that we're in this state. And that looks confusing because you're saying, well, B1 equals B1. Why? Why not just leave it as it is? Well, because there are other conditions. And we have to OR this. We'll end up ORing this with other expressions for B1. You see, we've already got an expression for B1 there. We've got another expression for B0 there. As a matter of fact, we're going to have yet one more expression. How will it begin? I'll go ahead and ask you, Mr. Christie. No, that's all right. All right, that's okay. When we're calculating, when we're trying to go to the stop state, we're trying to turn on B0. When we're trying to go to the get box state, we're trying to turn on B1. When we're trying to go to the fill box state, we need to turn on B2. So this expression will begin with B2. Okay? It's all right. We'll come back around. We'll get it. All right, Mr. Shepherd. I am programming this transition where prox is off and stop button is giving me a 1. That means the stop button is not pressed.
Okay.
How should my expression go over here? What should I add next?
Would be and or times B0?
I don't think there'd be any B0s here because B0 is a bit indicating the stop state. I don't think there's anything to do. What you're saying is, well, I'm not really sure what you're saying actually, because we're not programming either one of these. We're programming the get box
So
transition.
we're trying to get box and we're
We're
determining
in get box and we want to stay in get box. So what are the conditions
to stay in get
to
box.
stay in get box?
To stay in get box, we need to make sure that the motor is, or the stop
No,
button.
no, you're getting confused. We haven't done anything with outputs yet, so don't say anything about the motor or the valve. The magic of all this is that the outputs at the very end, they will be trivial to program. Because when B0 is on, when we're in the stop state, the motor and valve are off.
So we need to look at the inputs.
We're only
rather-
concerned with inputs right now. We're programming the transitions. So look over here, this transition is not going to help you much. Remember, these are the conditions that will determine where we go next. Right now, prox is off and stop is on.
Okay.
Okay, so what should I add here?
So right now B1 is the get box, so that'll, and we want, can you say that last part again?
Yeah, sure. Right now, prox is off and stop is on.
Okay,
So we want to stay in the get box state.
okay.
And these are our conditions. The stop and prox are our conditions. So what should I add next?
Stop PV.
Uh-huh.
I don't know how you can indicate is, what symbol you put to indicate that it's off.
Well, stop push button is actually on right now,
Okay.
right? So it's going to be a 1 in this state,
Okay.
or it's going to be a 1 in this box. So far we're in the get box state, that's 1, that's true.
That's
Ended with 1, so we've got true and true is true so far. You're doing good, because we need to get that to be true.
true.
So what next?
Then the last one that would determine whether we're in it or not would it be the fill box?
No, it has nothing to do with the
The
fill
next
box
stage.
state.
This
We're
thing.
just right here.
That's the output.
So far, you've programmed that condition, now let's program this
The
condition.
procs need to be off, so
Go ahead. I thought you were telling me.
it is.
Okay, so
I'm just trying to
and,
figure out the nomenclature for it.
okay, all right.
And get box is B1.
Well, we've already got B1 in
Oh,
there.
wait. Yeah. Oh, sorry, I'm looking for proximity.
Oh, you're fine.
Is it just